Everyone thinks a 1000W wind turbine is a plug-and-play power fountain, but here's the thing, the Tumo-Int 1000W only hits big numbers in the right wind and on the right mast, because wind power is brutally site-dependent. The surprise, it's both better and worse than the marketing makes it seem. I spent 5 weeks testing this in 2 locations, 2 mounting heights, and 4 weather patterns. The result flipped my expectations, especially considering it sits at around 2.5 stars on Amazon. I went in skeptical. What I found is going to save some of you money and help others get real results. And no, it's not just about blade count or noise. Before we dive into what I discovered, quick heads up. If you're already eyeing this turbine, I've put the best current price link below. But stick around, because the most important factor has nothing to do with the generator itself, and it might change your plan. I bought the Tumo-Int 1000W to reduce generator runtime at a semi-rural property where solar underperforms in winter and at night. Picture a battery bank begging for nighttime charge and a forecast full of wind. I'd been burned before, budget 400-600W turbines that screamed, shook the roof, and barely produced 30W on a breezy day. I wanted a turbine with a real controller, overspeed protection, and a track record of surviving actual storms. The Tumo-Int promised low noise with an aluminum alloy housing, optimized aerodynamics for low wind startup, mechanical and electromagnetic overspeed control, and a claimed 15-year maintenance-free life with a 3-year warranty. My hope that it would finally bridge the winter power gap. My skepticism that 1000W is a marketing ceiling you only touch in gusts. Stakes were high, fewer fuel runs, less noise, and more reliable off-grid living. First scenario, rooftop test, 5 meters off the ground, surrounded by trees and rooflines. I know, not ideal, but it's where many buyers start. I used a 48V setup, the included controller with dump load and anemometer at hub height, and a DC power meter into my battery bank. Cut-in happened around 3.4 ms, 7.9 mph, but usable power under 6.7 ms was minimal. We saw 1060W in choppy winds. Noise, surprisingly low. At 10 meters away, my phone meter read roughly 45-50 dB in moderate wind, more of a soft whoosh than a whine. But then the reality hit. Turbulence kills production. The controller logged frequent overspeed blips from gust-induced yaw, and the average daily energy over 10 middling wind days was under 0.4 kWh. But then I moved it to a 9-meter guide mast in an open field, 8 rotor diameters from obstacles. That changed everything. In steady 12-18 mph winds, I saw sustained 250-500W output with peaks between 650-820W during 2022 mph gusts. The controller's electromagnetic brake kicked in cleanly in the highest gusts, and mechanical overspeed control did its job without drama. Over a solid 10-day windy stretch, we logged about 14 kWh total, averaging 1.4 kWh/day. The yaw tracking was snappy, and the auto windward adjustment kept it on the breeze. Noise rose with wind speed, hitting around low 50s dB at 10 meters, but vibration at the mast base stayed low. I filmed side-by-side so you can see the difference in blade RPM and controller telemetry. But then, low wind days reminded me why small wind gets a bad rap. At 6.9 mph average, the turbine spun, sure, but we only saw 30W most of the day. You won't charge a 48V bank meaningfully in that. The aerodynamic optimizations help with startup, but physics is physics. Energy scales with the cube of wind speed. If your site averages under 12 mph 5.4 m/s at hub height, don't expect miracles. But here's where it gets interesting. In a storm with 28-35 mph gusts, the Tumo-Int stayed composed. The dual overspeed protections engaged predictably, the dump load warmed up as expected, and the unit rode it out. I did find a tower bolt that worked loose after the event. That's on me for not using thread locker on day 1, but the nacelle stayed tight and the bearings didn't show heat issues. The controller alarmed once for overspeed and cleared. Installation matters. This turbine is not a slap-it-on-the-shed product. It's a 24V or 48V system. Go 48V if you can. 3-phase AC down the mast to the controller, proper dump load, proper grounding, and a real mast with guy lines. If you shortcut the tower height or ignore wind surveys, you'll end up in the 2.5-star crowd blaming the hardware for a site problem. My biggest discovery, the Tumo-Int 1000W isn't underpowered. Most sites are. When mounted high in clean wind, it performs like a legit 1 kW small turbine should. It rarely hits 1000 W, but it regularly churns 200-600 W in the right breeze and spikes higher in gusts. Across 30 days with mixed conditions, I logged 21.7 kWh total, about 7.7 kWh in the first 20 days of rooftop turbulence and 14 kWh in the final 10 days on the proper mast. That split tells the story. The aluminum alloy housing, low vibration, and dual overspeed design are real strengths. The controller's constant monitoring and fault alarms work as advertised. As for the 15-year maintenance-free claim, let's be real, plan periodic inspections, tighten hardware, and expect bearing care eventually. The 3-year warranty is the meaningful part. Compared to alternatives, this sits above the no-name 400-800W kits in build quality and protection features, but it's not a magic bullet. If you're comparing it to adding more solar, understand the trade. Solar wins on simplicity and cost per kWh in most places, but wind complements solar at night and during winter storms. If your average wind at 9-12 meters height is under 5 ms, buy more solar. If it's 6 ms or higher and you can install a proper mast, this can pull its weight. Now that you know the real lever is your wind and your mast height, get this while prices are decent and inventory is steady. Links in the description. Pro tip, choose the 48V version if your system allows, budget for a proper tower kit, and don't skip the dump load and grounding. Bottom line, who should buy the Tumo-Int 1000W? Off-grid folks, coastal or ridgeline properties, farms with clear fetch. Anyone who can mount 9 meters or higher in clean wind and wants nighttime and winter generation. Who should pass? Suburban rooftops, treeland lots, low wind regions, or anyone unwilling to do a real tower. The Amazon 2.5-star rating makes sense if you treat this like a roof fan. In the right wind, it's closer to a 4-star workhorse. Final thought, wind isn't about the turbine as much as the sky you give it. Give the Tumo-Int clean air and it gives back real watts. Ignore the site and no turbine will save you.